Hi everybody, this is lesson 16, relating scale drawings to ratios and rates. So, how do scale drawings relate to ratios and rates? Write down your essential question and we'll get started. All right, if you take a look at those two images, the one on the left is actually the metro system here in Chicago, and then this one on the right is a fingerprint. Go ahead and fill in the blank. Is it a reduction or enlargement? And then subway system and fingerprint. So this should be pretty simple. Go ahead and think about what enlargement means, reduction means, and then drag those, well, I'll drag them. You write them in your workbook to see if you get it right. Okay, pause it and fill them in. Did you get that this is a reduction of a subway system? And that this is an enlargement of a fingerprint? Hopefully you got those correct. So what is a scale drawing? What is a scale drawing? It's a reduced or enlarged two-dimensional drawing of an original two-dimensional drawing. So whatever the original is, we're either reducing it or enlarging it. Okay, when you are done, let's move on to example 2. Example 2. If you notice on this picture here, it says that Derek's family took a trip to modern-day Public Garden. He looked at his map of the park that was a reduction of the map located on the garden entrance. Have you ever done that, though, where you see a map and you realize maybe it's facing a different way? So it looks like this has been turned a little bit. The dots represent the placement of the rare plants. So in the garden, obviously, they've got rare plants located here. So they're trying to figure out where to go to get to these rare plants. The diagram below is the top view as Derek held his map while looking at the posted map. So do you see how, like, if I took this one and kind of rotated it, it would then be facing the same way? So you might have to kind of turn your head a little to make sure that you're getting the correct points. I want you to go ahead and write point A corresponds to which point on the bigger map, and then point H, point V, and point Y. Go ahead and write those in, and then we'll see how you did. Okay, did you get that point A is to point R? And that point H is to point P? And that V is with W? And that Y is with N? Okay, some of them were easier, like the Y with the N, because I can see on the curve, the P with the H, because it's where they cross. I want to say the V with the W, that's where you might have had to imagine it being turned, and the A with the R. Okay, hopefully you did well on that. That's corresponding. Corresponding, think like matching. Okay, they go together. Which one corresponds with the other? Okay, we're going to skip this little robot one so you can put a big X over it. And we are going to go on to this one. And this is where we actually have to do some math. Celeste drew an outline of a building for a diagram she was making, and then drew a second one mimicking her original drawing. So that word mimicking is kind of where we realize that we're making a smaller version. State the coordinates of the vertices and fill in the table. For the vertices, we can do that, but what we really want to do is figure out the length. So go ahead on the original one. Count how many points we are from here to there and how far it is from here to there. And then it should be the same number since it's a rectangle. Okay, go ahead and count that and see what you get. Pause it and see what you get for the original. This is the original. Okay, fill them in right here. Sorry, fill them in right here for the original, the height and the length. Okay, if you're listening to me, hopefully you already did that. If not, pause it and do it now. Okay, did you get 18 for the height and 6 for the length? The vertices here are 7, 18, 7, 0, because we do the X first, then the Y, and then 13, 18 for this one up here, and 13, 0 down here. What these do is it tells you, okay, this is from 7 to 13, so that's where we got 6. They're 6 points away. And then from 0 to 18 is 18. So hopefully that's making sense to you where these came from. Okay, now do it for the second drawing. Pause it and count the length and the distance for the second drawing. Then unpause it and see if you got it right. Okay, did you get 9 and 3 for the new one? So what is the scale factor? What is the scale factor? We want to compare the scale length to the original length. So scale length to the original length. That means that the scale length, or the new image, we want to compare that to the original. New to original. So right now, go ahead and make two fractions. Compare the new length to the original length, and compare the new height to the original height. So make two fractions and let's see if you get them right. So both fractions, I want you to use this new versus original. In fact, I'm going to copy it down here for you, and we're also going to put another one here. So new versus original. I want you to do it with both numbers. Okay, the new one was 9 in length, or sorry, the height, and the original was 18 in height. Okay, so remember the new one was 9 and the original was 18, so 9 over 18. If you didn't get that one right, now try and fix your second one and see if you can get that one right. Okay, the new image over the original is 3 going across, and the original was 6 going across. So did you get 3 over 6? They both equal the same thing. What does 9 over 18 and 3 over 6 equal to or reduce to? It is 1/2. So that's our scale factor. Scale factor is 1/2. Okay, hopefully that made sense to you. Sometimes we're getting bigger, sometimes we're getting smaller. Since we got smaller, that makes sense that it's a scale factor of 1/2. So the dimensions on the new one are 1/2 of the dimensions on the original. So 3 over 6 and 9 over 18 both equal 1/2. Okay, and then good news is we're actually going to skip this one as well. If you want to try it, you can. I'll give you a hint though. This is actually not going to be proportional because there isn't the same scale factor for the length and the width. So when I say length and width, I'm talking about these two here and these two here. Okay, so you can try it if you like, but you actually don't get the same number when you reduce, and I think that can be confusing to some of you since I really just want you to focus on what a scale drawing is. So go ahead and copy in your vocabulary for scale drawing, reduction, enlargement, and one-to-one correspondence. So that's right there on page 68. And once you're done, you're done. That's the entire video. How exciting, only 8 minutes. Okay, I'll see you in class.